Hi, this is Majid Haidari from Ozen Engineering. So this is a third part of my video regarding simulating of AR/VR using ANSYS optics and photonics. So in previous part we learned how we can simulate a 1D grating, 2D grating using Lumerical. So now we want to do ray tracing. But for the ray tracing, we have two boundaries. The first, is a ray optics, and the second is a wave optics. So for the wave optics, we need to simulate using Lumerical. For the ray optics, we can use the Zemax. So in this part, I will introduce a dynamic link between Lumerical and Zemax. So this is the workflow. You see. For the first part, this is a grating structure that we need for design a 1D and 2D grating, and here is the Zemax. So in this part, in this section, we will do the ray tracing, and we measure the power at the pupil. So it's a dynamic workflow between Zemax and Lumerical. I will show you how it works, and then in the next section I will describe how we can optimize the structure. So let's go and see the simulation in the Zemax. So let's I will open the Zemax. You can find the information of this topic as a 1D 2D rating in our knowledge base article. So okay, so let's open the Zemax. So I open the Zemax here. So I want to open the Zemax file. You can download this file from our knowledge base article. So let's open. Okay, yes, okay, so I'm waiting for the. So you see, when we open the file, is Zemax also open two Lumerical file. So if we go to the two Lumerical file, so the first file is 1D grating. So in the 1D grating, I described in my previous video that how RCWA works. So like you see here is a top cell. So in the top cell, these are the different parameters, different structure that we have. Like for instance, this is polygon 0, 1, 2. This is our polygon. So this is our base. This is top cover, and so you can change the material. If you right click on the top cell and select edit object, you see that you can change the periodic X, Y, and the refractive index of negative, positive, the duty cycle, depths, top cover, base. You can change all the parameters here. But this is the script that this script assigned this variable to the variable regarding to the structure. Okay, so let's go to the Z. This is for 1D. For the 2D grating, because we have 1D and 2D grating in the AR/VR glasses. So for the 2D, this is a 2D structure, periodic structure. So this is our rod and the slab, and positive and negative part of the material. So if you go to the circle, so top cell, go to the property, you can see the the parameter periodic x, periodic y, the value of refractive index. So, and also for instance for the circle, if I right click on the circle and edit object and go to material, you can see this is a hole. I mean, this is a slab. We have a slab and we have hole through the slab. So and our slab material is 3.4. So we have a slab material with the 3.4 and we have a hole inside the the slab. So for the RCWA, the parameter that you can see there, propagation direction is forward. This is geometry and solver and excitation. So like we have a table, we have a different angle for the theta and phi. So just for the simulation in the back end of the Zemax, we use this table for the RCWA. Okay, so let's go to the Zemax. On the Zemax side, this is the Zemax. On the Zemax side, as you see here, we have 5 rows. So the first row is the the main parameters here is the row number 2 and number 3. For the number 2, if I select the number 2 and if I go to the object 2, I mean it's a 1D grating, you see it's highlighted here, and select the object and go to the diffraction. You see that the address is 224r1.fsp. That is it this file you see here, 2024r1.fsp. These are the parameters, you see, period x. Let's I reduce the size, and also meanwhile I open the Lumerical. So you see here, if I right click on the top cell and select edit object, so you can see so the period x is 0.366. You see the period x, period y 0.1, and then the UD cycle 0.65, depth. You can see, you see that these parameters, when we change the parameter on the Zemax, so automatically this parameter changed on the Lumerical side. For instance, if I put the 0.4 here and see the parameter on the Lumerical, you see that the parameter changed to 0.4. Okay, so if I let's come back to 0.36, you see also the period in the shape changes corresponding to the Lumerical side, 0.36. I mean, this is a dynamic workflow between Zemax and Lumerical. Okay, so this is our surface 2. Our surface 2 is a diffractive grating. So you see it's a 1D, and you see it's highlighted here. So you can see the Z position of this one is 0 and y is -5. Okay, so for the second one, I mean the second one is a 2D grating. You see, if you go to the diffraction, and you see it's a 2D grating. So I mean this file, 2D grating. We can change also, we can see the variable here. If I right click on the top cell, select edit object. You see that the period X is 0.42, period Y is 0.36, and the radius, slab, index, everything that you can change, and you can see like for instance if I change it to like 0.5, you can see how it changed in the numerical side. Okay, so just I want to make sure that we're working in a sorry, just let me. Okay, so I mean so this is a dynamic workflow between Lumerical and Zemax. So now in the Zemax side, so we have 1D grating, we have 2D grating, and also this is our source. We use the lip source, and this is our detector, you see here. So now it's clear for us, this is also non-sequential mode, so we need to work on non-sequential mode. Okay, so 1D, and this is 2D. Okay, so in the next step we want to like see the results. So what we want to do, so first of all we are working on a non-sequential ray tracing, and we determined that our source and our detector. So for the parameters that we simulate, I remember also we changed the the 2D grating. So let's run this simulation, and then we can discuss about the result. So if I go to the analyze and then ray tracing, and so I can do a clear and trace. So you can see that also if you look at the numerical 1D and 2D grating, you can see how it works. So now in the Zemax side, we're waiting for the results. So it's very like optimum solution between ray tracing and wave optics. So now the result is ready. So we can see like this is a detector viewer. We can see the linear view first. So if you look at the linear view, so we can see that this is the intensity distribution, and so the peak irradiance, you can see it's around 0.84 milliwatt per centimeter square, and this is the total power. So we can also increase the number of rays to let's see to see the more rays. So I can increase to, let's say, 10 rays. Let's clear and trace. So I increase the number of rays. So it takes some time. Okay, so it's finished now. You can see if I go like use rays, let's say wavelengths, we change the wavelength. You see how the light distributed, how light coupled the 1D, this is 1D, and out coupled to from the 2D. Okay, So now, like, we can change the parameters here. Let's uh, so if you look at the peak power, this is the peak power. Now imagine that we want to change the parameter to, like, let's say instead of 0.36 put 0.4. Okay, and run the simulation. You see in the backend we have a numerical, and then ray tracing, clear and trace. So actually in the numerical, for different angle, for theta and phi, RCWA calculate the reflection and transmission, and then we use those data and the Zemax. So I'm waiting for the results. You see in the numerical side. Okay, the results almost finished. Okay, so if you like look at the result in the peak radiance and the total power, you see a different value. So it shows that I mean we can optimize the it's much better now. So if you look at also in the larger scale, you can see how light this is the detector viewer of the incoherent irradiance. So yeah, I mean uh, this gives us some opportunity to optimize the 1D and 2D grating. I hope you enjoyed this video, and if you have any question, please send email to us, and yeah, we will find we will talk together. Thanks.